Okay, so again, we put in our numbers of the different bears that we found on our sample. We can see here what we estimated this to be. And then when we look at those estimates, we can see that compared to the real number, this yellow was an overestimate of the yellow, and this was an underestimate of the brown. So again, like we would say on Tuesday, here with our data, it would appear as though there is a significant difference between the yellow and the brown bears. But since we have the luxury of knowing our actual data, there really is not a significant difference. So we have a problem because our data that we collected from our samples was not representative of the population. Okay, so that's an issue. So we have to discuss that, because if this happens, then it is worth nothing. You should just throw it out and start over. Anytime you have bad data, you cannot overcome it. All right, so how did our classroom outside bear hunt compare to the expected probabilities? And this is on the back of your bear hunt lab. So how did our outside ones compare to what we expected to happen? We found that what? The orange and green were about as expected. Okay, but what did we find out about the yellow and the brown? Okay, we overestimated the yellow and we underestimated the brown. Okay, so the next question is, well, what happened? We overestimated the yellow and we underestimated the brown. But why do you think that happened? Why do you think that happened?
It's easier to see the yellow.
Perfect.
Harder to see the brown.
Good. It was easier to see the yellow and harder to see the brown. So that occurred. We have just this physical impairment that we cannot overcome with the brightness of the M&Ms and how we were able to see them. So let's talk about the difference between our population versus sample, and then we're going to talk about overcoming that problem. Okay, so when we talk about the word population, what do you think that, what part of our lab are we referring to? Population would be the what? Good. The population is all of our bears. All the bears that we had in Aledo Forest. Okay, so all the bears that we had in Aledo Forest. So all the ones that I took and I distributed amongst the forest was our population. And then we went and took samples to try and see if our samples were representative of the population. Okay. Okay, so you're gonna give me her. Wow. Okay. So, what are we going to say our sample is? Okay, good. So that would be each student's results. Okay, so we had, in this case, 30 samples. Okay, so we had 30 samples so that we could collect those results. Now, here's the next question. Because I told you that the results that we got before were poor. They did not represent the population correctly. They overestimated the yellows and underestimated the browns, so they were messed up. They were not representative of the population. How can we overcome that? So this question arises. How large does your sample size need to be in order to get valid sampling results? So what do you think? What we put maybe 10 people up there about, so what do you think? Anybody know maybe how large it needs to be to overcome the results? Maybe more? Okay, so we'll, somewhere along the lines of more. Well, let's just look at what happens if we select more samples. Okay, so who's somebody that didn't go? Riley, you didn't go, right? Did you? You didn't go. Okay, tell me your, actually let's just do that table right over there. I don't think any of y'all did. Okay, so y'all all tell me your orange percentages. Okay, you ready? Okay, go orange.
46.
46.
38.
38. 50. And
48.
48. Okay, so look, I got more data. Is this looking like it's going to fix the problem with more data? No, if nothing else, it actually might improve my thought that orange is higher than 35. Okay? So the fact that I got more, it's not going to necessarily improve my opinion. It may even rise this estimate of 35. Well, let's do it with yellow. You guys tell me your yellows. What were your yellow numbers?
21%.
21,
28.
28, 43,
20.
23, okay.
That's really
18.
18. Okay, so there's those numbers. Do I think adding those to our mix might help?
No.
It might lower it a little bit. Okay, so maybe let's collect more. Did anybody go on that back table there? Okay, so you guys without Paul. Okay, go. Oh, okay.
Yeah.
Y'all all back. Go.
Separate.
What's more? Kyle, go. What's
Okay.
your yellow?
22%.
22. Okay. 32. Okay, Paul.
I said
You already. Oh, sorry.
15.
15. Okay. And then Rob.
Already won. That's already won.
Oh, okay. Ashley.
For orange.
Yellow.
Oh, yellow.
13.
13.
Okay. Dang. So that's not proving my point. But getting more, we do kind of look like we are getting a little closer. So that's not doing what I wanted it to do. And that happens sometimes with data. Who else did go? I'm gonna keep doing this. You guys, okay, Isabel, Bailey, go.
33%.
33, Bailey.
41.
Oh, look at that. 41 on yellow. Okay. So I took some more. Look at those. With the introduction of those, we might still consider maintaining our overinflated estimate of yellow. The point that was supposed to be more obvious is that no sample, or no,
Size does not.
size, that would be a better way of putting it. Thank you. Size of sample cannot fix a bad design. If I have 30 estimates that are all overinflated, and then I collect 100 more people go in your same forest, they're still going to get overinflated amounts of yellow because they still had the same bias. So you cannot fix a bad design once you have something wrong with it. In our case, we had this physical impairment of only being able to see the lighter M&Ms better than the darker M&Ms, and so we were visually what? Impaired. True, we were visually impaired, but typically when you favor one group over another, what do you call that? Good. We are visually impaired, which renders our results are visually biased. So they are not fixable. That's a bad design. You throw it out and you start over, and you figure out a better way to take get a population estimate. All right. So that was basically that was the whole meaning behind this bear hunt. That how to collect the sample, go through that process, and understand that if you do it in a poor manner, then it's useless. So the questions that you posed on Tuesday, when we go through this experimental design unit, you need to make sure that you are thinking about how you should collect your data. And so that you can collect your data properly, so that you do not have bias, you have done it randomly, and you're not imposing any type of influence on it, whether conscious or subconscious. Okay, so that's that one. We'll end that recording, and I don't know how to fix that thing right there.